Good morning, good evening, good afternoon. This is Kannan Muthukarupan, co-founder at Yugabyte. It's my pleasure to welcome you to another session of the Yugabyte DB Friday Tech Talks by engineers for engineers. And it's one of my favorite topics today. And I'd like to welcome Hemant Bhanawat to today's session. Who'll be talking about performance debugging. And Hemant, over to you. It would be great if you can introduce yourself, what you do at Yugabyte, and as well as then you can get started on the topic.
Sure. Thanks, Kannan. Hey, everyone. Thanks for joining. I'm Hemant Bhanawat. I'm Director of Engineering at Yugabyte. I deal with performance at Yugabyte. In this presentation, we will be talking about performance debugging for Yugabyte database. The agenda is going to be straightforward. We will first talk about few common reasons that cause performance problems. So these are the general reasons which we have seen at a lot of customer environments, and we'll be talking about them, that what are these common reasons. Then we will talk about the available mechanisms that are there to debug such problems, right? You hit a problem, but now you want to debug it. So for that, you need some tools from Yugabyte to debug that problem, and we'll be talking about the tools that are available. And finally, we'll delve a bit deeper into how to do the debugging, right? We'll talk about a bunch of different approaches, which are like first things that you will do when you have to debug the system, right? I'm calling it a cheat sheet because this is not an extensive list or an exhaustive list of things that performance engineering would entail, would have, because performance engineering can be a vast topic. But the approaches that we discuss here have solved 70 to 80% of the customer cases that we have worked with, right? We have been able to figure out what the actual problems have been. Yeah, so let's start. What are the common reasons? I think these are pretty intuitive. There is no rocket science to them. One of the most common reason that we hear is schema issues. We see at a lot of places wherein the schema is not appropriate, and that causes the queries to slow down or throughput to be less. One of the examples definitely is missing indexes, right? You fire a query and you have a where clause on a column which does not have an index, and you end up scanning the entire table, right? And that causes a lot of performance issues. So that is one thing. If the data is not partitioned correctly, that can also cause performance issues. Hot rows and shards. I think this is an interesting problem. I think Kannan, you might have, we discussed it a couple of times for some of the customers, right, Kannan?
Yeah. So, I mean, for example, it may so happen that in your data set, one particular row is hot. Maybe your app has designed is keeping track of total number of transactions in a row, and so every transaction now has to increment that counter. So even though you have a distributed database, if you're going after the same row and everybody's trying to do x equals x plus 1 of that row, it is going to create a hotspot. So that's one where you have to consider the trade-offs of the application design. Is it possible to shard that counter and take the penalty on the read path to then merge the counter? Another example is a hot shard, where for example, it's not a particular row that is hot, but let's say you created a table or an index that is sorted by timestamp. And so your shards are sort of ascending in nature. The oldest shards have the lowest timestamp and so on. And all write activity, all new inserts might be coming in at the current timestamp. So sort of the rightmost shard of your table is where all the activity is. So these are all flavors of situations that can create a hotspot in the system.
Correct, correct. And we have seen it at more than one customer location. So yeah, definitely, I think these are important ones.
And I think you'll cover some of the ways to identify if this scenario is happening in the system, right?
Yeah. Yes, absolutely. Yeah. Another reason is a CPU bottleneck, right? You might see a lot of CPU being utilized, and that is the reason. And reason for CPU bottleneck can be a bunch of different reasons than actual overload, right? So that is also is a common reason we see in a lot of customer environments. Another is a higher network latency. I mean, the Yugabyte is a distributed database. In a lot of customer environments, we are distributed across regions. And that is where I think it is important to understand how the network latency is playing an overall game, right? Sometimes it happens that customer feels that the query are actually slower, but it may be a config issue, a data placement issue, or something related to that, which can be just fixed with some adjustments, right? So that is one of the things. One of the important things that we have seen, I think, is disk bandwidth issues, right? So in cloud environment, the number of IOPS that you have for every disk, or the bandwidth that is allocated to a disk, is at a certain level, right? And if your system or your application needs a lot more bandwidth, you will end up hitting those limits. And in those cases, the system slows down if you are hitting those limits, right? Another thing is, even for the disk related issues, we have seen in certain customer environments where they were using Kubernetes and they didn't configure their subsystem correctly, right? So the disks were actually slower. So that also caused some performance issues, right? And finally, memory bottleneck, although this is not one of the major reasons, this is like we see it in very few places, but this also comes up in certain discussions wherein customers see some performance issues before the memory bottleneck. So we'll go to that. No, not actually memory bottleneck, but yeah, incorrect configuration of memory. Or yeah. So we'll look through them one by one. Yeah, before we jump into the actual debugging, now, what are the available mechanisms with Yugabyte DB? I will show them each one of them one by one, but let's talk through them first. There are a bunch of different things that you can use with Yugabyte for perf debugging. The foremost is the metrics. We have this metrics page available, which can be scraped by a Prometheus server. And this Prometheus server can store those metrics, and then those metrics can eventually be showed inside a Grafana dashboard, right? So that is how you can go about the metrics. The Grafana dashboard, we have a pre-created JSON that anyone can use to create a Grafana dashboard. You can add more advanced queries if you are looking for some specific results or some specific insights into the system, right? So you can use Grafana. We have our own tool, which is a YB Anywhere, which shows these things in a very YB specific way, is what I should say, right? So when it is YB specific, we take out the right things and show it to you, right? So I will go through that as well. And then there are a bunch of different endpoints available. Using them, you can do, for example, to check the tablet distribution. Tablet is a unit of partition in Yugabyte. So you can use the tablet distributions, how the tablets are distributed, where are they located, right? That you can check using a endpoint tablet servers. Then we have a statements page. This page lists down all the queries that have been fired on that particular server, and what are the latencies of those queries, right? We are also working on bucketing those latencies, right? So that kind of thing we are doing. Then we have these active connections, right? What is the current activity that is going on the system? How is the memory distribution looks like? And finally, threads. I will come to them. Let's look at them before we go anywhere, right? So let me take you to first the Yugabyte main page. This is the UI for our master server, right? It has got a bunch of details here. One of the interesting details is the tablet servers. This can tell you the tablet distribution, right? The tablet servers endpoint I was talking about. This tells you the tablet distribution. It tells me that there are 3 tablet servers, and these are the different tablets that we have, right? And leaders is an important aspect in Yugabyte, because every read and write inside Yugabyte flows through the leader, and leader has 2 followers, right? So how many number of leaders are there on a node will define that how much load that system will get, right? So it is important to understand these leaders, right? We also have certain like easy to read metrics here, which is read and write operations, which gives a quick idea that what is the activity that is currently going on in the system, right? The interesting part of this page is the utilities, or maybe let's go to one of the T servers, because this is the master server on which you can have a look at different utilities. Let's go to one of the T servers and see the utilities. What are the utilities that are available? So like I said, one of the important things that is available is what are the current live operations like. For example, on this machine, there are a bunch of different connections, and each connection, there are some queries going on in this system, although these looks like uh, what do you call them? These looks like just the metadata queries fired from inside. But yeah, it gives you an idea that how many connections are open and that kind of thing. Similarly, there is one page for YSQL. So we have YSQL page live operation. You can also have a look at the queries, right? This is the statements page, right? It tells you which queries have been fired, what is their latencies, how many times that particular query have been called, right? These queries are normalized and jumbled. So we keep all the queries of similar type in the same bucket here. It gives you a decent idea of what is the workload in the system, how are the queries performing, right? So that is another important aspect, another important endpoint that one can look at, right?
And
Yeah.
if you if you look at the last two, the why, if you just stay on the previous page, maybe
Sure.
yeah, the bottom two, like YSQL live ops and YSQL all ops. For those of you who are familiar with Postgres, that information is also something that we expose via PG stat activity and PG stat statement. So one is like, what's the live activity on the system and what's sort of the historical activity on the system.
Absolutely. Yeah, makes sense. Yeah, and that is an important aspect because you sometimes don't need the endpoint. You can just fire some queries on your SQL shell and get this data. Yeah. Yeah, and then there is this memory breakdown, right? This memory breakdown, although it is like a long list of things and not everyone will understand what it is, but it gives you an idea that what is the current consumption, what was my peak consumption, and what is the limit, right? In case you are hitting limit sometime, you might want to scroll a little down and try to understand if there is one particular bucket which is causing a lot of memory, and that might give you some hints, right? So that is another way to look at this particular thing. Yeah, so I didn't talk about the metrics, right? So we have these Prometheus metrics available, or the metrics which can be scraped by Prometheus rather. There are like hundreds of these metrics that Prometheus can scrape from Yugabyte at a regular interval, and then Grafana can be used to plot charts on it, right? So this is another metrics endpoint. And finally, this is a little bit an advanced thing, which is the stack traces of the current threads. But sometimes what happens if their query is extremely slow, you might want to go there here and just look at all the threads and how many threads are doing same type of operations, right? On different servers, and that might give you an idea, right? It is not always like you will know the exact answer, but it will give you some pointers that, okay, probably my scans are taking a lot of time, or probably the aggregation is taking a lot of time. So those kind of hints you can get from this page.
Yeah, usually if there's a thread buildup with a lot of threads waiting on a common resource, or if there's sometimes it can point to an inefficiency in Yugabyte database that our team needs to help improve. So these stack traces can give an insight into what is keeping the system busy right now.
Correct. This is very helpful even in the development aspect. I mean, when we develop the Yugabyte, this is really helpful. But yeah, it helps.
There is one question coming in, Hemant, which is like, hey, if the leader is going to get more calls, does that node need more resources than the others? And could that node kind of become a bottleneck?
Yes, exactly. Because if you, in case of affinitized leaders, all the reads will be coming to your one single node. So yes, that node will have to be a beefy node in that. And then you want to add there, yeah.
Yeah, I might take a slightly different color to it or stance on it. If you go back to your tablet servers page, I mean, go back to your the port 7000 for YB master, and then.
Oops, sorry,
I think you need a.
Yeah, I have. Yeah.
So if you look at the column 4, notice that there is no specific, like, so first let's just talk about, I think Hemant's answer was a little bit more on advanced usage for multi-region deployments. Typically in a single region deployment, there is no notion of a leader node. Like you see that there are about 62 leaders on the first node, 61 leaders on the second node, and 61 leaders on the next node. So tables are automatically sharded, leaders are fairly uniformly distributed. So as such, there's no notion of a single node becoming a bottleneck unless you have a hot row problem or a hot shard problem. So that's sort of a different problem, right? And then the second thing that Hemant was referring to is like, hey, this is a if you could scroll down a little bit, Hemant, on this page, you will see that in this particular cluster, actually it is a multi-region cluster, US East 1, West 1, West 2. So there are some advantages, and we covered this in a different talk, where you might decide to nominate the nodes in just US East 1 as your preferred zone. In this example, there is 111 node here, but let's say it's 10, 10, 10 nodes. Then if you choose only US East 1 as your preferred zone, then you're absolutely correct that these 10 nodes might be doing a little more work than the other 20 nodes. But then there are tricks like, you can use follower reads to read from the other nodes instead of reading from readers. So that's a whole topic of its own. Right. And maybe while we are on it, if we could go back to the utilities page here on YB Master, because it's a multi-region cluster, go to the utilities page and scroll down. And there is look at the T server clocks, right? And that will also give you, and there's a column called heartbeat round trip time, like maybe the 6th, It kind of tells you roughly like the latencies between these data centers. So there's a convenient page to look at, like saying, hey, your nodes are heartbeating to the YB master leader. And one of the nodes is just 1.8 milliseconds away, rough give or take, but one is like, so it gives you a quick idea of the ping latencies in this particular deployment. That can also be a helpful tool in performance debugging.
Yeah, and this could be really important in certain cases when one region is really far from others because they are read and write paths. Yeah, so this is good to understand. Okay, now let me go to the Grafana page. I think what I showed you was a metrics page, right? You can collect those metrics in Prometheus and use our Grafana JSON. I've used this Grafana JSON, and you can see that all the metrics are plotted here, right? So you can see the YSQL connections and YSQL latency, right? For example, this is a YSQL ops, which is giving you number of operations across all nodes, right? If you want to delve a little deeper, maybe you might want to go and change the query inside it, and it may show some extra details, right? For example, let me try, it's taking a bit of time. Let me try adding the node to the query, right? So what it will do is it will show me number of inserts that are going on in say on a single node, right? Rather than showing me the average across all nodes, right? So these are the tricks that I can play. Let it come. Yeah. So like you can see here, it was showing me that there are 3 different nodes here, and for each of the nodes, there are about 250 plus operations going on, each of these insert operations going on, right? So these are the things that you can try out with Prometheus queries and get a lot of information out of it. We have, for this demo, I will be using this YB Anywhere, which is our own tool, and this tool has done some work to simplify it further, right? So this is YB Anywhere, and you can see the similar metrics here in different tabs, and there will be a bit more information and a bit more usability than Grafana page, right? So that is where we use this particular page.
Just for context, YB Anywhere is, think of it as a self-service control plane or a DBAS layer for Yugabyte. And the metrics, it has a very rich metrics component to do things like outlier analysis. Is my traffic uniformly distributed between nodes, or is one node getting more traffic, and so on.
Absolutely. Okay, now let me go to the actual mechanisms. How do we go about it? Regarding the perf debugging, right? One of the things we talked about was the high CPU utilization, right? So what are the reasons when I can see a high CPU utilization, right? So one of the common reasons is that one node is more overloaded than others, right? And one of the reasons why this could happen is that your app is only connecting to one node and there is no smart driver in between. You are using some other type, either PG driver or maybe a driver which is not smart, and you are directly connecting to a particular node and all traffic is going to that node, right? For example, if I can explain here, it's coming up. Yeah. So if I can explain here, we have these bunch of different operations going on, right? You can see a select workload here, about 1600 operations. And if I just select that outlier nodes, right, it's just a way to tell that differentiate this thing. Yeah, and then let me select the select workload, right? So now what you can see is that the entire workload is coming to your node N2, right? The entire workload. So that means that the workload is coming to one particular node, and that node will be more loaded, right? So for example, if I go to the CPU utilization of this node, again, if you see, this node has got 10% CPU utilization, while this is the average, right? The two nodes are at 1 or 2%, right? So effectively, there is no CPU utilization on the rest of the two nodes, and one node is heavily loaded, right? So you might want to change your app so that it connects instead of one node to all the three nodes, right? So those are the things that is one of the reasons we have seen why CPU utilization could be high, right? And one of the things, yeah, go ahead, Kanan.
Is there a corresponding connections graph when we can see the same?
Great point, great point. Yes. So I think if I go here, you can see that all the graphs are all the connections right now are, this is the total YSQL connections, number of connections that has been made, right? So you can see that there are about 84, 85, 80 connections roughly, right? So it averages out to 28 per node, but actually only one node is taking the entire load, right?
Got it. The red line is the average line, and then there are three lines. Two of them are at 0. Yeah.
0 almost. Yeah, correct, correct. So this is a very useful thing that one needs to look at, right? Another is tablet distribution and affinity. I think we talked already about it when Kanan was explaining about the tablet distribution, right? So in case you have the entire tablets affinitized to one leader, probably you will have to think about that, how I can do a better job of reading, right? So like Kanan said, probably using follower reads or other things so that we don't hit the bottleneck on CPU bottleneck on one particular node, right? Then there are a bunch of different background activities that happens with Yugabyte, right? One of them is flushing, and another is compaction. These things are very internal, and they happen inside our storage subsystem, which we call as DocDB, right? So if you want to see how they are happening, because these activity are both CPU intensives and intensive activity and disk intensive activities. We have throttled them, but if your workload is anyway at a very high CPU utilization, and if these activities kick in, sometimes you can see a throttled performance, right? And you might see either drops in throughput, right? So this DocDB is a good page to go and look for these background activities, right? So one of the background activities I said was flushes. Flushes is since the right select workload was running, you don't see any flushes happening right now. But if it is an insert plus select workload, you will start seeing some flushes. So flushes will take the data from memory and push it to disk. So that is what you might want to look at. You might also want to look at if compaction is eating a lot of memory, right? So how much compaction is happening. These graphs cannot be evaluated in like isolation. You will need some comparison, right? You will know that my workload was running great here, but now it is taking some time. So that comparison makes it very easy to go about it, right? There is one more thing that takes some time, and which is tablets, the remote bootstrap, right? So remote bootstrap is also captured here in the T server, right? It's a tablet server related activity. So if there is another node which is coming up and which is reading a lot of data from one node and writing it to itself, that activity is also CPU intensive. So that is one of the things. One of the things, if you do not find any answer, probably it's good to ask yourself, is actually the cluster undersized? I mean, how many operations are you carrying out on this cluster, and is that cluster undersized? We will publish some guidelines around it, that what is the sizing, but they will still be rough. You will have to know your cluster and understand where they are, right? The final point, which can consume a lot of CPU, is unoptimized query. Yeah, so unoptimized query we will discuss a bit in the next section. Yeah, I'm a little
one question coming in
yeah.
Is there a way to find out the root cause behind such an uneven distribution? We might have partly answered that question, like when we took your CPU example, right, Hemant?
Yes, exactly. So uneven distribution, yeah.
The uneven distribution between nodes.
Correct. So, like I said, the app connecting to only one node is causing you the hotspot, right? That is one of the reasons, right? So that can be fixed by having introducing a smart driver in between, or maybe connecting to all three nodes and doing the round robin, or using a pool. Those are the things that can help you. The second reason is tablet distribution. I think we also covered that to a certain extent. Yes.
Yeah, so in general, that's why like the performance debugging is, I think we called it a little bit of an art and a science.
Yeah.
You start with something, and I'm sure some of the, there are probably more AI kind of techniques we can use to automatically guide us towards the right answer. But in this particular example, the flow we took was, we noticed that CPU was higher on one node. We started looking at some of the other graphs and noticed that, oh, there are more connections coming into one node, but the reasons could be different, right? Maybe the connections are coming evenly to all nodes, but the row
Correct.
that these connections are interested in, that's sitting in one node. So then you got to, we have the T server level metrics to figure out, like the DocDB level metrics, and it would have,
Yeah.
that pattern would have shown up there.
Yeah, absolutely. Yes, next is which queries are running slow, right? So for example, let's take this example. Here you can see that number of ops are very less, but if you see the latencies of the queries, they are like touching about 60 seconds, 80 seconds, right? Those are the numbers that it is touching, right? So this average latency, I'm looking at the tablet server, right? So just wanted to talk about it as well. You have a latency at YSQL level, right? Which is the query layer. So query layer sees a latency, and then it fires a call to a storage node, which could be a different machine altogether in a different region. And that is where the processing actually happens, and that latency is captured here. So you have now two latencies. One is the query layer latency, and another is the tablet server latency. So when I see the tablet server latency in this case, you can see that it is going up to 60 to 80 milliseconds, 80 seconds, right? So which is too huge. Now, the immediate thing that you should do in such scenarios is check whether which queries are offending, right? 80 seconds is a very huge time. Even the network latencies may not justify that kind of number, right? So if you quickly go to the statements page that we showed earlier, right? You just go to all SQL ops and try to see which queries are taking a lot of time, right? So now what you realize here is that this particular query is taking 83 seconds, right? And this is an offending query, which means either there is no index on this ID, right? Or somehow this is getting into an entire table scan, right? And that is why it is taking 83 seconds. That is one of the most common reasons we have seen. If you go after, let's say, if this range is small, or if this is an index based thing, probably it could be much faster, because your index will be sorted on a particular on ID, and then between query will work extremely fast, right? So if you see here, there are multiple such queries which are causing this thing, right? A high mean time. If I just highlight the mean time, right? This query was fast, right? This is just an ID equal to 1. This went extremely fast, but as soon as the query was between, it took a lot of time, right? And there are hundreds of such queries here, right? This took 29 seconds, right? So this is one of the place where I will know which is my offending query, and then I will take that query and run it on explain analyze, and I will check if there it is an index scan or a index only scan, and I will go after query debugging rather than the system debugging if one particular query is offending, right? Another place where we see a lot of challenges is sometimes we have this incorrect usage of prepared statements, right? And when you have incorrect usage of prepared statements, you prepare statements very often, right? And that preparation may cause certain calls to master server, and that master server calls are master server is our metadata server, right? So that metadata fetching can be in certain cases took a lot of time. It will take time only for the first prepared statement, but if you are creating prepared statement one after the other, it might give you headaches, right? So it might be good to have a look at this get tablet locations page and see if it is actually, if there are too many calls, metadata calls here, right? So this is an important metrics that we look at a lot of times, right? To understand if there are any metadata calls which are actually slowing down my queries. Yeah, another thing I think which might need an entire session is leadership changes, right? We have certain times leadership changes which can cause query retries. We have a metrics for that. Just because of the shortage of time, I'm not going there, right? Hot rows and hot shards, I think Kannan explained in the beginning. Yeah. Now let's go to the higher network latency. This is a very interesting thing because what happens is, like I explained earlier, there are these two different types of latencies. Why the query layer latencies and T-server latencies, and there is third one, which is the client latencies. Now, why these three are different? Because we are a distributed system. Your client may be in a different zone or a region. Your T-server can be in a, sorry, your query layer might be in a different zone, and your actual place where the query gets processed by the T-server could be in a different zone, right? So these three latencies, you have to take care to understand what is my network latency and if that is playing a role, right? So for example, let's go here quickly. Let me remove these insert and select. Let's see the query here. The query I'm in the MySQL tab, right? So this is observed by this latency is observed by the query layer. My query layer says that I took 30 milliseconds to process this particular query. But when I go to tablet, right, these are averaged out. So I've just fired some queries here. So that is why you, but in your case, it could be a little bit more tricky, but I think it could be figured out. Now, if you see here, the tablet server latency for a read, right, there could be a bunch of different reads here, but it is like in 0.5 millisecond. It does not justify the 60 times jump to 30 millisecond. And that is where it tells me that your latencies are in the higher side, right? Your network latencies are in the higher side, right? So this is a good indicator. Another indicator is that when you are running from your client, the latencies that you see in your client side versus the latencies that you see here on the MySQL page, they are a lot different. Probably there is something inside the network latency that is playing a role, and that is a cause of a problem at a lot of customer sites, right? Because one has to understand that.
And in this case, I think we already saw it. It's because it's a multi-region deployment, and
yes, absolutely.
And maybe the request is coming into one region, and the row is in region B or region C, and we saw one region is about 60 milliseconds away, another one is about 20 milliseconds away.
Correct. Absolutely. I should have explained it in the beginning, maybe, yeah, because I think this is coming up. Yeah, so exactly, this problem will not be seen if your cluster is all local, right? You will have the same query layer latency versus the tablet server latency. Since I wanted to highlight this point, I had made this kind of setup.
Yeah.
Okay, there are actually one more important thing. We have these read and write paths which are different. In read, your SQL client directly reaches to the tablet leader and reads the data from there, right? It is directly reading the data from here, while your write has to write the data to two different nodes, right? It will only wait for the reply from one node and then it will come back, but still this write will have to wait. So if there is a lot of distance between two T servers, it will be like your write latencies will be different than read latencies, even though your client is in the same region as where you are firing the queries, right? So that is also one of the reasons why people sometimes say that my read queries are fast, but my insert queries are slow, right? This could be one of the reasons because there is an extra network latency that comes in between the write path. Disk ops slowing down. Yeah, this is also a very common problem we have seen, right? For example, oops, open it in the same window. Okay. So a lot of times, like I said, disk bandwidths get hit, right? And in certain cases, disk is a problem when there are too many cache misses, right? We have this block cache, and if the block cache gets invalidated either because of compaction or remote bootstrap or any other admin activity, you will see a lot of disk reads happening because now your cache is invalidated. You need to read from disk, right? In those cases, I think for a certain period of time, the queries may, the latencies may shoot up, but it will be minor. But that is what you need to see if your caches are getting invalidated, right? So for example, in this particular scenario, if you see, I have configured about 3000 ops and they are getting hit, right? And even with, I'm sorry, yeah, even with, there are about like 530 connections, right? This is a large number of connections. And even with 530 connections, I'm not able to take CPU beyond 30%, right? So which tells me the bottleneck is somewhere else. And then when I look deeper, I realize that my disk IOPS are at 3000, a little more than 3000. And that is what the limit I have set, right? So there I either need to increase my read bandwidth, or I need disk bandwidth, or I need to change something in my queries, right? So that is what I would like to have a look at from a disk IOPS perspective. The cache misses that I was talking about is again a number which tells you that for the read workload, how many times I hit the cache and how many times I miss the cache, right? If this number goes up, which means your caches are getting invalidated and there might be a reason for it, either a compaction or a flush or something like that is happening, which is causing this to get invalidated, and you see a higher.
The only thing I would say there is it may not necessarily just be an invalidation case due to compaction or flush, Hemant. What could be happening is maybe the available RAM is like 8 gig, but your data set size is like 500 gig. So fundamentally, if your data set doesn't fit in memory, there will be
Correct.
blocked caches. I mean, it's more like
Yes.
evictions due to data set size being larger than the available RAM. And then, like you said, if you configured your cloud instance to provide 3000 provisioned IOPS, the easy fix here might be to increase the provisioned IOPS to 6000. Like if you truly, your nature of the data set is larger, right?
Correct. Yeah. Absolutely. Yeah. So, and one of the things that we do a lot of times when we realize that, I mean, everything is going well, but I don't see the performance, right? We check the disk disk latencies as well, right? For checking the disk latencies, FIO is a very good tool. It takes 2 minutes to run FIO on any customer machine, and you can quickly figure out what exactly the problem, how fast or how slow is my disk, right? That might give you some idea. Yeah. Last 1 minute from my side. The memory issues, right? This memory issues, I think this is not, I mean, we have not seen a lot of time when memory causing the performance degradation. It is like memory configuration that causes performance degradation. For example, the block cache example, I think, Kannan, you were giving that block cache example the other day, right? In the block cache configuration, if you have a, like we say about 50% of the memory should be allocated to block cache, and on let's say 4 GB machine or 8 GB machine, that 50% is 4 GB. So you have left 4 GB for your rest of processes. But on a, let's say, 64 GB machine, you have left 32 GB for the rest of the things, right? So it's a balance that you have to take, and we provide a lot of guidelines. Our Yugabyte Managed has all those settings already done. But if you are running it on your own, probably those are the settings you might want to have a look at and see if your block cache and mem table, which are two high consumers of memory, being given enough memory. If the memory is not enough, you will end up seeing some performance degradation. So yeah, and if there are too many open connections, each connection has some memory overhead, and that is what we might want to look and see, use a pool and remove all the idle connections, right? That also helps a lot of times, right?
Exactly.
So yeah, I think there are too many things that could be discussed from a performance debugging perspective. This is just like a primer, and but it will help you in a lot of scenarios, right, if these approaches are followed. So yeah, thank you for your time and thanks for listening. I'm happy to take any questions if there are.
I think there's one more question in. Are there any metrics to see if the latency is high because of conflicting transactions, or is that not common? We do have metrics for transaction conflicts.
Yes, I think if the transaction conflicts, let me find that. Yeah, this is the transaction conflicts that you see, right?
Yeah.
So this is the metrics that it is under the DocDB thing, because it is more like a storage subsystem thing. So yeah, we have this.
Maybe one final question we'll take, which was like, I think the question was, do you do debugging? Is the debugging done one node at a time, or do you do it in groups of nodes?
I think it is more like in what approach do you take? Because I mean, everyone might have a different approach, like we discussed. I generally take a high-level view in the beginning and then start going by them. I mean, like I explained, I start with the CPU usage, then I go to the statements page, and then look at the tablet distribution, and then look at a bunch of DocDB metrics related to compaction. And I use this feature much, which is the outlier nodes. While looking at every metrics, I keep this feature on. So it gives me an idea that, okay, if one node is behaving differently, suddenly I will focus my energies on that node. That is my approach, but I think this is an art everyone will have. Yeah.
I agree with that philosophy. I mean, we have had customers or users with 100+ node clusters, right? So taking a top-down approach, like that's why a lot of the graphs that you start with initially will tell you average latencies, P99 latencies, but all of that is cluster-wide. And then you kind of
Sure.
start your performance debugging there, figure out which problem you want to go after, then do analysis like, is the problem due to one node being hot, or is the problem maybe due to one index being hot or one shard being hot, or maybe you have indexes that are not even getting used in the read path, but you're paying a lot of cost updating them in the right path. So outlier, just like outlier nodes, if you hover over outlier tables, that will kind of give you information on tables or indexes that are most used, least used. You can do top K, bottom K kind of analysis. If you scroll a little bit up, there you see the top, bottom. So right now the toggle is set at top, but you can also say like, which are my least used tables or indexes? Variety of different techniques. This is always a fascinating subject,
and you can do all this magic in Grafana as well, right? These are just Grafana queries in the behind. You don't really need this thing. So even for open source work users, it is it should work perfectly.
Thanks for staying a little bit beyond time, everyone. Thank you all for joining. See you next week on another episode. Thank you, Hemant, so much for this wonderful topic and coverage on a wide variety of tips and techniques.
It was great to talk to everyone. Thank you for all the questions.
Yeah. All right. You all have a good rest of the weekend.